Hi, and welcome to this new collection of tutorial videos on the new procedural generation plugin in Unreal Engine. I'm Adrien Logu, tools programmer at Epic Games, and I'm working within the procedural team. This collection of videos is aimed for people to learn about this new plugin that will be released as an experimental plugin in 5.2. So multiple disclaimers. First, this plugin is released as experimental, so you can learn a bit more what it means in the Unreal documentation. I will put the link in the description. For the purpose of those videos, I'm building my own binaries of Unreal Engine. It's Unreal 5.2 branch on GitHub. Some features presented in this video will be in 5.2 Preview 1, but not all of them, as we are actively working on this plugin and it's changing constantly. Since it's experimental, some features could not be in the final version, and will probably break retrocompatibility at some point. We try to be careful, but sometimes it's not always possible. And even if I'm working on Unreal, I do not know everything about Unreal, so I might do stuff that are suboptimal. Alright, so for this build, we'll see what we can do with the plugin, how to enable it, and we talk a bit about the system, and we start generating some stuff. So this is the result that we're going to have at the end of this demo. The plugin enables people to define rules to procedurally generate content, and one of the most common use is scattering on the surface. On this map, you have this forest, and you want to scatter some trees on your map, and that is the goal of this first video. Let's start from the new map and see how we can achieve this. So let's create a new level. It will be a basic level. We can just remove the floor, and we will create a landscape. So I have this landscape right there. Very simple one. And we just want to make sure that PCG is enabled. So for that, you go to Edit Plugins, then you can start to write procedural, and you will see the procedural content generation framework there. You can enable it, restart the editor. To make sure that it's activated, you can go to Place Actor, try to write PCG volume, and if you have the volume, it means that it succeeded. So PCG volumes. PCG volume is a very simple box that we can drop into our world like this. It contains a PCG component that will also contain a PCG graph that will have all the rules for generating content. And the box will usually define the bounds of the generation. So in my case, I want it to be a bit bigger. So I'm going to go with the 50 there. So I have like a bigger box like this, and we will create a new graph. So let's go to the instance graph and then create a new asset PCG graph. I'm just going to say, I don't know, forest. All right. So now that we have our graph created, we can open it, and it will open a new editor that is very similar to what Blueprint is. So you have like some nodes like this. You can flow some data by connecting edges. You can have inputs and you have outputs, and outputs can be useful if you want to chain multiple rows together. So you have a lot of nodes you can see on the left pane. You can also right click and see that all the nodes. Some of the nodes are defined natively in C++. Some of them are also defined in blueprints that allows people to prototype very quickly. If you want to create new node in C++, you can. You can also prototype in Blueprint, which makes it very, very easy and flexible. We'll see how to do that in the future videos, but for now, we're just going to scatter some points in the landscape. To do so, we have a node called the surface sampler. You can start to write it, have the surface sampler. It will add you a new node. What we want is we want to be able to sample a surface. So take some point on one surface. So what we do is we want to go to do the input, and you can find there multiple types of inputs. In our case, you have the landscape and landscape height. The landscape contains more information than just the height, but in our case, we only need the height. So we're just going to use that one. So just click and drag it into the surface. So now I can go to my component and click generate, and that's a bit anticlimactic, isn't it? Our graph generating some point, but we didn't tell him to spawn anything. But we can still verify that the generation finished. With the generation, you can check generate, and you can see that it's checked, so it means that the graph is executed correctly and managed to get some computation done. To make sure that we have points, you can right click on the node that you want to analyze, go inspect, then you can select one component that is generated, And you will have a list of all the points that got generated by this node. So you can see in our case, we have a lot of points that were generated, which is good. It means that we had something, but we don't see anything in our world. So to help you debug when you are designing your rules, we also have a debug option. You can click debug and ta-da, you have some points that are scattered on the landscape. So you can see exactly all the points that are generated. And in the list, you can see this position, the rotation, the scale, and a lot of different information that is interesting. What is also interesting is that if you are modifying the bounds, it will also regenerate it automatically. So if you are moving the box a bit, you can see that it generates new stuff. If I make it a bit smaller, it will rescale and sample in this new range. So it will regenerate automatically. What also is interesting is you can see that the points have different color. For the debug information, it's related to the density that's stated in this column. So a density of 0 is black and a density of 1 is white. Density is between 0 and 1. In the case of the surface sampler, the density is also random by default. Now that we have our points, we can play a bit with the surface sampler and its settings. So on the right, if you click on it, on the right, you can see the few options that are available. And you can change of them and the graph will be automatically regenerated. So if we change our number of points, I say I want less points, I can just say I want like 10 times less points, you will have less points. If I want more, I can just try to reset it to the previous value. And you can verify that the points generated are exactly the same. It's because the surface sampler node is deterministic. So it means that if you are setting exactly the same settings, you will have exactly the same result. So in our case, we also want to try to have more points. So let's say I do 0.5, but there is nothing that has changed. So I wanted more points, but I didn't get more. That's because each point has some bounds, some extent, and the surface sampler will put points as a certain distance from each other. So it means that if I want more points, I need to reduce its extent. Or you can also change the looseness. So if I change the looseness, let's say I want it to be less loose, you can see that the points are closer to each other. And I can increase it to have something that is very, very close. And I can also change the extent. If I put them half their size, you will see that I have more points because the points are smaller. And if I go back to 0.1, you can see that you have less points. So the thing is, the generation is deterministic. So if you change the seed, you can have different results. So I don't know, put random seeds, it will change automatically. So you can have a seed on the surface sampler directly, but you can also have a seed on the component directly, which means with this exact same graph, you can have different seeds that will produce different results, which allow you to reuse the same graph and have different results. One other thing that is supported with PCG is that you have this workflow that can be done in the editor. So you are generating the points directly into the editor, but you can also do it runtime. So if I'm cleaning up the component, you can see that I have this generation trigger that is generate on load. So it means that when the volume is loaded in game, it will generate. So if I click play, you can see that it's generated at runtime directly. So it means that you can generate PCG during gameplay. And we'll see how to do that in the future videos. But for now, we're just going to focus on editor flow. So we'll just regenerate them. So points like this are not very interesting. So we're going to add some trees. So for that, I will just use trees that I found on Marketplace. I have this plugin that has a few trees that are interesting. So I added them to my project. So you can see they are there. So to spawn new stuff, we are going to disable the inspection, disable the debug, and then we'll have a new node that is called the static mesh spawner. So what you want to do with the static mesh spawner is to take the points that are output by the surface sampler and plug them into the static mesh spawner. Right now there is nothing that is outputted. That's because we didn't specify which mesh we want to spawn. So let's go into our mesh entries, and then you can find the descriptor, and you can specify a static mesh there. You can use anything you want, doesn't matter. And there you have it. Just selecting the mesh will spawn trees there. And I have a lot of trees, which is not exactly realistic. So I'm just going to play a bit with the settings. For the fast sampler, let's say I want less trees. So it's better. Point extents, I will let it there. Perhaps I want them closer to each other. And I don't know, just play a bit with the seed. And there you have it. You have added a few trees in your game. Hit play. You can see that the trees, if they has collision meshes, they will have collisions. All right. So we have one tree, which is not the greatest forest ever. So we'll add a bit more variety. So what I will do is I will add new entries, and by default it just will select based on the weight. So in my case I have one weight everywhere, so it means that I have as many chances to take one mesh to the other and then the other. So if I just take this one, and I will take this one, and this one, and yeah, now I have 4 different trees. Last one. And what if I wanted to have this kind of trees like 50% of the time, and this kind of trees 50% of the time? So if I just increase the weight of this one to 3, the sum of all the weights will be 6. So 3 divided by 6 is 0.5. So it means I have a 50% chance to spawn this one, and I will have a 1/6 chance to select the other ones. So by doing so, you can see that I have more trees of this type. And now we have a balanced forest. So final touch for this episode, all meshes are spawned with the same scale and rotation. So it means that they are all the same size. All the trees have the same size, as you can see, and have the same orientation. So to counter that, we will just add a new node that we call transform point. So what we want to do is to get the points from the surface sampler and put it back into the static mesh panel. And we want to remove this one. So to remove edges, you can just press Alt and click. So we have the same thing because the transform point is not doing anything right now. But you can see on the right that you have multiple things that you can do. So first, let's say I want to have trees that have a scale between 50% of their scale and 100%. So I can just change this minimum scale by 0.5. And you can see that the trees have changed sizes. So now that we pick randomly a size between 50% and 100%. You have seen the difference, but we can also see this in debug. So if I press E to disable the static mesh panel, and then I press D for debug the transform point, you can see the boxes have different sizes. So you have one that are bigger and one that are smaller. But exactly what we want is that we want to have like some randomness in the sizes of the trees. One thing that we can also do is try to have a random orientation. So if we want to rotate them randomly on the z-axis, we can just set the rotation max to be between 0 and 360 in degrees. And then you have it. You have all your points that have different orientation. So if I disable debug and re-enable the static mesh panel, now my trees have different sizes and different orientation. and it's still working at runtime. So if I want to clean up and press play, it gets generated at the beginning. And this concludes our first tutorial episode for PCG in Unreal. We'll see more functionalities in the next videos. So if you have any questions, you can try to post them in the comment section or reach out in the Unreal community forums. Until next time, have fun with the plugin. Take care.